Time is not a straight line. It loops, it hides, it remembers, buried beneath sands, written in forgotten scripts, encoded in the stars. They never wanted us to find. This is eternal vault, from the lost world of the ancients to the future we are not yet ready to see. You're not just watching a video. Let the vault reveal everything. Will we one day call another planet home? Will cities rise on the dusty plains of Mars, or beneath the golden haze of Titan's thick atmosphere? The idea of humans colonizing other planets has ignited our imagination for centuries. But now, with advancing technology and ambitious goals from organizations like SpaceX and NASA, this ancient dream may be closer to reality than we've ever imagined. For centuries, we've looked up at the stars and wondered what lies beyond. Ancient civilizations created stories of gods living on the moon and planets. In the modern age, that curiosity evolved into science fiction, where humans build space stations, terraform alien worlds, and create civilizations among the stars. These stories reflect a deep longing not just to explore, but to expand, to push past the limits of Earth and ensure that humanity becomes a truly spacefaring species. But colonizing another planet is far more complicated than launching a rocket or sending a rover. Colonization means people living, working, reproducing, and surviving independently from Earth. It means building entire ecosystems and sustainable systems of life in places that are, by nature, hostile to life as we know it. Let's begin with Mars, the planet most often considered for colonization. Mars is relatively close in cosmic terms and has some Earth-like features. It has a day just a little longer than Earth's, ice at its poles, and gravity, although only about 38% of Earth's. There's even evidence that liquid water once flowed on its surface. But Mars is not welcoming. Its atmosphere is incredibly thin and composed almost entirely of carbon dioxide. Temperatures are extremely cold, averaging -80 degrees Fahrenheit, and the surface is regularly bombarded with radiation. Despite this, Elon Musk's SpaceX has set its sights firmly on Mars. Musk envisions a city of 1 million people living on Mars by the end of this century. His company's Starship rocket is being developed to make space travel cheaper, faster, and more reliable, with the long-term goal of carrying human passengers to Mars. NASA, too, has made significant strides toward future Mars missions, with plans to send astronauts in the coming decades as part of their Artemis program. Yet even if we can get to Mars, surviving there poses enormous challenges. The journey alone takes 6 to 9 months, depending on orbital alignment. That's half a year of exposure to microgravity, isolation, and cosmic radiation. And that's just one way. A round-trip mission to Mars could easily take 2 to 3 years. Transporting not only humans but also life support systems, shelter, tools, food, and fuel becomes a logistical nightmare. Once on Mars, settlers would need to build airtight habitats to withstand the thin atmosphere and freezing temperatures. These habitats would have to maintain stable internal temperatures, recycle air and water, and protect against radiation. Cosmic rays and solar storms can penetrate the thin Martian atmosphere and damage human tissue, electronics, and DNA. To shield settlers, scientists are exploring ideas like underground habitats, water-filled walls, and radiation-resistant materials. Food production is another hurdle. There's no fertile soil on Mars, and sunlight is weaker than on Earth. Scientists are developing hydroponic and aeroponic systems to grow food in controlled environments. But creating a stable and varied diet over many years remains a challenge. Water will need to be extracted from underground ice and recycled endlessly. Oxygen will likely come from chemical processes like electrolysis, or from experimental systems like NASA's MOXIE, which converts carbon dioxide into oxygen. Beyond physical survival, the mental health of colonists is also a major concern. Long periods of isolation, confined living conditions, and lack of social interaction can lead to depression, anxiety, and even psychosis. Earth-based analog missions, like those in Antarctica or in Mars simulation domes, show how fragile group dynamics can be in high-stress, low-contact environments. Designing support systems, psychological protocols, and communication links with Earth will be essential. And yet, the technologies we are developing to tackle these problems are progressing rapidly. Reusable rockets, once considered a fantasy, are now launching regularly. Artificial intelligence is being trained to operate autonomous robots that could build habitats before humans arrive. 3D printing could be used to create shelters out of Martian regolith. Even waste management systems are being designed to recycle every ounce of material from air and water to human waste. Propulsion is another critical area of development. Traditional chemical rockets are powerful, but inefficient for deep space travel. Newer systems like ion drives, nuclear thermal propulsion, and even theoretical concepts like antimatter propulsion promise faster journeys and reduced fuel requirements. Shorter travel times would not only save money, but also reduce the physiological toll on astronauts. One of the most radical ideas is terraforming, the process of altering a planet's atmosphere and climate to make it more Earth-like. On Mars, this could involve releasing greenhouse gases to warm the planet, melt the polar ice caps, and thicken the atmosphere. That could eventually lead to the creation of lakes, rain, and possibly even breathable air. Other ideas include building orbital mirrors to direct sunlight, or using genetically engineered organisms to produce oxygen. Of course, terraforming is still theoretical. It would take centuries, if not millennia, to achieve any meaningful change in a planet's environment. But even partial terraforming, like raising surface temperatures or increasing air pressure slightly, could make life on Mars significantly more manageable. While Mars remains the focus, it's not our only option. The Moon, though barren, is much closer, only 3 days away. NASA and other agencies plan to build lunar bases as way stations for further exploration. Its proximity makes it ideal for testing life support systems and long-term habitation. Meanwhile, icy moons like Europa or Enceladus might harbor subsurface oceans that could one day support life. Titan, Saturn's largest moon, has a thick atmosphere and lakes of liquid methane. It's bizarre by Earth standards, but potentially useful in ways we don't yet understand. The technologies being developed for space colonization are already impacting life on Earth. Solar power, water purification systems, compact food production techniques, and sustainable construction methods are just a few examples of how space research can benefit humanity here and now. The push to colonize other planets is driving innovation in robotics, AI, materials, science, and energy. Fields that will shape the future whether we live on one planet or many. But why go at all? Why invest trillions of dollars and untold human effort into building cities on dead planets? The answer lies in our nature as explorers, as survivors, and as thinkers. Earth is a beautiful, life-sustaining planet, but it is not invincible. It faces threats from climate change, overpopulation, pandemics, nuclear war, and even asteroid impacts. Colonizing other planets offers a backup, a way to ensure the continuity of human civilization in case of disaster. Stephen Hawking warned that humanity must become a multi-planetary species if it is to survive the next 1,000 years. Carl Sagan spoke of the need to safeguard the continuity of life by spreading beyond Earth. It's not just science fiction, it's a strategy for survival. Yet colonization also raises difficult ethical questions. What if Mars already has microbial life? Do we have the right to alter or destroy it? Who owns the planets? Will space colonization benefit all of humanity, or only the wealthy and powerful? Could we repeat the colonial injustices of Earth's past on a cosmic scale? International law, like the Outer Space Treaty, currently prohibits nations from claiming celestial bodies as their own. But private companies, resource mining ventures, and national pride are already testing the limits of these agreements. As we move forward, we must ask not only what we can do, but what we should do. If humans are to colonize other planets, there must be a sustainable economic model to support life off Earth. Colonies cannot rely indefinitely on supply chains from Earth, which are expensive, slow, and vulnerable. In the long term, interplanetary colonies must become economically self-sufficient. One potential revenue source is resource extraction. Asteroids and moons are rich in rare metals like platinum, gold, and iridium, resources that are essential for electronics and manufacturing. Companies like Planetary Resources and Deep Space Industries have already laid early plans for asteroid mining. If successful, these operations could supply Earth with critical minerals while supporting the growth of off-world economies. Mars also holds resources that might sustain a colony. Perchlorates in its soil can be processed to extract oxygen. Regolith can be used for construction. Underground ice can supply water. Solar energy is abundant, though weaker than on Earth. The colony could generate energy, mine raw materials, and even manufacture tools and parts using 3D printers fed by local materials. This concept is known as in situ resource utilization, ISRU, and it is key to sustainable colonization. Trade could also play a role. As colonies develop, they may specialize in products or services uniquely suited to their environments. Data processing centers, for instance, could benefit from the extreme cold on the Moon or Mars. Scientific tourism might flourish as wealthy individuals pay millions for once-in-a-lifetime experiences on alien worlds. Over time, colonies could become economically interdependent, forming a web of interplanetary commerce. Just as nations compete on Earth, they will inevitably compete in space. The 21st century is seeing a new space race, not just between the US and Russia, as during the Cold War, but now also involving China, India, the European Union, private corporations, and even smaller nations aiming for a slice of the cosmos. China's space program has made dramatic strides, including landing a rover on the Moon's far side, launching a space station, and planning missions to Mars and Jupiter's moons. India has also made its mark, becoming the first nation to land on the Moon's South Pole in 2023. As these countries expand their ambitions, geopolitical tensions could follow them into space. Who controls Mars? Who decides mining rights on the Moon? What happens when two countries want to build settlements in the same location? The 1967 Outer Space Treaty prohibits national claims of sovereignty in space, but enforcement is vague. Without clear governance, there is potential for conflict, especially if valuable resources are at stake. To prevent disputes, a new framework for space governance may be needed, something like a United Nations of Space. It would set laws, resolve conflicts, manage shared resources, and ensure that space remains a domain for peaceful exploration rather than militarization or corporate monopolization. As we adapt to living on other planets, human biology may begin to change. Mars has only 1/3 of Earth's gravity. The Moon has 1/6. In low gravity, muscles weaken, bones lose density, and blood redistributes in the body. If humans live for generations in such environments, evolutionary pressures could reshape our physiology. Future Martians may grow taller due to weaker gravity. Their bones may become lighter. Their hearts and circulatory systems may adapt to altered blood flow. Children born in space or on Mars could develop differently than Earth-born humans. Over centuries, we may even see the emergence of subspecies adapted to alien worlds. Radiation is another factor. Without Earth's magnetic field and thick atmosphere, colonists on Mars or the Moon will be exposed to high levels of cosmic rays and solar radiation. Over time, this may lead to increased mutation rates. Genetic engineering may become necessary, not just for protection, but also to adapt to extreme environments. CRISPR and other technologies could one day modify our DNA to resist radiation, produce vitamins internally, or breathe thinner air. This raises profound ethical questions. Should we alter our species to fit new worlds, or terraform worlds to fit us? Perhaps the future holds both, a gradual co-evolution of humans and the planets they inhabit. The private sector is becoming a dominant force in space exploration. Companies like SpaceX, Blue Origin, Axiom Space, and Rocket Lab are revolutionizing space access. Unlike national space agencies, these companies move faster, innovate aggressively, and take higher risks. SpaceX, for example, is building the Starship to carry 100+ people to Mars. Blue Origin plans to build Orbital Reef, a private space station. Axiom aims to build commercial modules attached to the ISS and later form independent habitats. These companies are creating a foundation for a new space economy, where tourism, manufacturing, and even real estate expand beyond Earth. This commercialization could dramatically lower costs. SpaceX's reusability model has already slashed launch prices. In the future, companies might offer services like satellite repair, asteroid towing, or in-orbit construction. Space hotels may cater to the ultra-wealthy. Moon or Mars colonies might begin as scientific outposts, but eventually evolve into thriving business hubs. However, unregulated commercialization risks repeating mistakes from Earth: environmental destruction, labor exploitation, wealth inequality. International frameworks will be necessary to balance profit with responsibility, ensuring that outer space remains open and fair. To live off-world, humans will need new skills. Future colonists must be engineers, doctors, farmers, geologists, and psychologists, all rolled into one. Training programs must prepare them for emergencies, isolation, scientific work, and survival in harsh environments. Space agencies already conduct analog missions in deserts, caves, and underwater habitats. These simulations test equipment, psychology, and logistics. In the future, training may involve virtual reality simulations of alien terrain, or even AI tutors that guide settlers in real time. space universities may emerge, offering degrees in off-world agriculture, space medicine, habitat engineering, and interplanetary law. Education will need to be interdisciplinary, immersive, and continuous, especially for children born in colonies. Schools on Mars will not only teach Earth's history, but also the colony's founding story, values, and responsibilities. Long-term success will depend on passing knowledge across generations. Education will be the backbone of civilization building in space. Life on another planet won't just be about survival, it will be about living. Colonies will develop unique cultures, holidays, traditions, and identities. Martian art, music, cuisine, and language may evolve differently from Earth's. The psychological need for meaning and belonging will drive settlers to build communities with shared values. A Martian identity may emerge, just as immigrants formed new nationalities on Earth. Celebrations may mark the day of landing, the first birth on Mars, or milestones in terraforming. Over time, cultural divergence may widen, especially if communication with Earth is limited by distance. Religion may evolve too. Some settlers may interpret their mission spiritually, seeing themselves as caretakers or pioneers of life. Others may form new belief systems based on the cosmos. Art and literature will reflect the awe, fear, and wonder of living among the stars. Life on another planet will be physically alien, but emotionally human. Love, family, hope, grief, and dreams will shape the new societies that arise far from Earth. Colonizing Mars or the Moon is only the first step. The true frontier lies in the stars. Alpha Centauri, the closest star system, is over 4 light-years away. At current speeds, it would take tens of thousands of years to reach. But new technologies may change that. Ideas like the Breakthrough Starshot project aim to send gram-scale probes using light sails pushed by lasers. Fusion propulsion, antimatter engines, or warp drives, if ever realized, could make interstellar travel feasible. It may take centuries, but humanity's curiosity will not stop at our solar system. Generation ships, massive spacecraft where entire communities live for hundreds of years, are another possibility. These ships would be mobile worlds, self-sustaining and designed for long-term survival. Ethics, governance, and cultural design would be as critical as engineering. If we succeed, our species may one day spread to habitable exoplanets, carrying with us not just biology, but memory, history, and dreams. We will be stardust reaching back to the stars. Humanity's journey into space is not just a technological challenge, it is a civilizational evolution. Colonizing other planets will test our science, ethics, unity, and imagination. It may take decades or centuries. It may be fraught with setbacks. But the dream is alive. To survive, to thrive, and to fulfill our deepest aspirations, we must look up and reach out. The universe is vast. Our story has just begun. Human colonization of other planets is not inevitable. It may fail. It may take longer than we expect. But even the effort itself will transform us, scientifically, culturally, and morally. It will force us to reconsider what it means to be human, to live not as Earthlings, but as citizens of the cosmos. The road ahead is filled with challenges, technological, environmental, psychological, and ethical. Yet we are already walking it. Every Mars rover, every satellite launch, every international collaboration in space brings us a step closer. We stand at the edge of a new era, one where humanity could take its first real steps into the larger universe.